Day 18 of 90, and today we fixed the bug that haunts every junior JavaScript dev, errors that vanish. Here's the scenario. You wire up an async click handler, it calls an API, and when that call fails, nothing happens. No error in the console, no message to the user, and your UI just freezes. The button looks clickable but it's dead. You wrapped it in try-catch, so why didn't it catch anything? By the end of this video you'll know exactly why async errors slip past try-catch, and how to build error handling that actually makes decisions instead of swallowing failures. Look at this broken handler. We have button.addEventListener, click, equals, try, fetch user, catch, showerer, The problem, fetch user returns a promise. That try block finishes instantly, before the promise rejects. The synchronous code ran fine, so catch never fires. When the rejection finally lands, there's no handler waiting, and it becomes an unhandled rejection that disappears. This is the single most common error handling mistake I see. Try-catch only catches what happens synchronously inside the block. A floating promise rejects later, on its own timeline, completely outside that block's reach. The fix is one keyword, await, placed inside the try. Make the handler async, then try, await fetch user, catch, showerer, Now await pauses execution and rethrows the rejection as a real synchronous throw at that exact line, so catch sees it. The rule to tattoo on your brain, try-catch only catches awaited promises. No await, no catch. This is also why .then, .catch, and async/await differ. If you throw inside a .then, callback, only a following .catch sees it, a surrounding try-catch won't, because that callback runs later, detached from your stack. Catching the error is step 1. Step 2 is deciding what to do. Most juniors catch console.log and return undefined, which just moves the silent failure one layer up. Instead, give your errors context. Build a custom error class app error extends error, constructor, message, code, super, message, this.name equals app error, this.code equals code. Now throw new app error, user not found, user _not _found. That code field is the magic. It lets upstream handlers branch on what kind of failure happened instead of parsing error message strings, which break the moment someone rewars the text. Here's where it pays off: one top-level handler that reads the code and decides. Catch, switch, code, case network, return retry, case auth, return redirect to login, case user _not _found, return show message, no such user, default, log and rethrow, See what changed? Every layer below just throws typed errors and stays dumb. The decision lives in exactly one place. Retry, show a message, redirect, or log and rethrow, that's a real decision tree, not a pile of defensive try-catches that each quietly give up and return undefined. Let's apply this to a fetch wrapper with retry. Async function fetch with retry, URL, retries equals 3. Inside, await the fetch. If response.ok is false, check the status, retry on transient failures 408, 429, and 5xx, but throw immediately on 4xx like 404, because retrying and not found just wastes time. On a retryable status, wait with exponential backoff, await sleep, to attempt *100, then loop. When retries run out, throw new API error, message, status, retry count. Now your React hook catches the typed API error and renders a real error state with a retry button instead of a frozen, blank screen. But what about errors you never anticipated? You need a global safety net. In node services, add process.on, unhandled rejection, error, equals, log structured, error, process.exit, 1, and the same for uncaught exception. Counterintuitive rule: when you hit an uncaught exception, log it, flush your metrics, and exit with code 1, do not try to recover. The process is now in an unknown, corrupted state. Let your process manager restart it clean. In the browser, the equivalent is window.addEventListener, unhandled rejection, to report errors you missed instead of letting them die silently in the console. Day 18 done. The one takeaway: error handling isn't about preventing errors, it's about deciding what your code does next when they happen. Await inside try, throw typed errors with codes, decide once at the top, and put a global net underneath. Subscribe for day 19.